So again, thank you very much for coming to another seminar on Fridays. Today is the day of Noelia. She has started very recently her PhD at the IMSES group under the supervision of Pablo Arechavala, and she will be talking about her PhD ideas and also part of some results she obtained during her master thesis that she also did it with Pablo here. So thank you very much, Noelia, and the floor is yours.
Thank you too. Thank you everyone for coming today. First of all, I want to apologize for the further mistakes in English I will do. And I hope you enjoyed the presentation. So I said, in EcoSets, I'm going to present my PhD thesis, which title at the moment is The Implication of the Environmental Enrichment on Welfare on the European Seabass. And we have to analysis the behavior, physiological, and cognitive abilities of the European seabass. So to provide some context about the aquaculture industry, we have to say that even though its growth in last years, where is the pointer? Here. Even though its growth in last years, their breeding conditions are often inadequate because of their lack of stimulation, being a breeding condition that are extreme homogeneous, uniform, and with no changes. This breeding condition can lead to negative effects on welfare and also in their cognitive abilities and prevent the achievement of positive welfare. To understand the consequences or the reason for this consequence, we need to go back to the concept of welfare. Brooms defines welfare as the state of an organism in relation to its attempts to adapt to the environment. And therefore, any modification in this environment will affect the welfare status of the individuals. So in last years, there were a concept of welfare based on homeostasis, and it defines a relationship between welfare and environmental challenges. The relationship that they defined was a negative linear relationship, and that means that the complete absence of welfare leads to good welfare. The complete absence of environmental challenge leads to good welfare. In recent years, this concept, a new concept of welfare has emerged and based on an allostatic concept, suggesting another relationship between welfare and environmental challenges. This new concept explains that on the complete absence of environmental challenges and also an extreme intensity of these environmental challenges will provoke a bad welfare. And there are an optimal range of this environmental challenge intensity that would lead good welfare. So this concept is really important to differentiate the normal adaptive stress response to those situations that lead to an extreme stress for the organisms. So a good welfare is characterized by the capacity of the organisms to prevent and react to the environmental challenges in a way that matches the environmental demands. So a welfare can be divided into three aspects, starting with the emotional one, that are here. Here it includes the psychological state of this individual, taking into account the cognitive abilities, like for example, learning or cognition, but also their emotional states, like for example, fear or pain. On the other hand, we have the natural state of the individual, and in this case, it involves the behavior, taking into account the social behavior, like socialization, but also the behavior of each individual, like for example, personality or response to stress. And finally, we have the functional state, which involves the physiological functioning of the individual, like for example, growing or physiological response to stress. So in order to increase these environmental challenges and then reduce the homogeneity of the breeding conditions, the environmental enrichment is understood or is considered an effective tool, and is understood as provide environmental stimulation to help to satisfy the psychological, physiological, and behavioral needs of the fishes, enhancing their ability to cope with these captive conditions. There are 5 types of environmental enrichment, and one of the most popular ones are the physical or structural environmental enrichment, which is understood as adding physical complexity to the environment through some structures or objects that increase the heterogeneity of these breeding conditions. Another type of environmental enrichment is the occupational one, and in this case, it involves introduce different challenges or control over their environment, as well as encouraging physical environment, like for example, adding water currents to the environment to enhance our active swim in these environmental. And in this case, it's important because this prevent the monotony and therefore reduce their boredom. So there are three types of enrichment missing. There are the sensorial, the dietary, and the social one. So the effects of the environmental enrichment would be different to each species and also in each life stage. So each environmental enrichment strategy will produce different effects to each species. In this diagram, it shows the number of articles that are investigating the effect of physical or structural environmental enrichment. As an overall of this graph, we can say that a lot of studies focus on ornamental and experimental species, while research about the commercially cultivated species are very limited, apart from salmoniferms. There are really a lot of studies about them. And especially the studies about the European seabass are mostly non-existent, even though it's one of the most farmed species in the aquaculture in Europe. That's why the objective of my PhD thesis is to assess the effect of two different types of enrichment, one the physical one and the other the occupational one, at two different temporal scales on the overall welfare of the European seabass. So in order to achieve this objective, this methodology was proposed. We need to carry out two experiments if we want to compare the effects of both enrichment. So the first experiment was the physical one and then the occupational one. These two experiments need to have the same methodology in order to have the same parameters, making them comparable. So currently, the physical experimental about the physical enrichment experiment is already done. And we are now analyzing all data collected during this process. So this physical experiment was conducted at Limia facilities, obviously in Mallorca. A total of 4,000 juvenile seabass were moved to experimental sea cages, and we applied the enrichment to 4 of the 8 cages, leaving 4 cages without any kind of treatment. The structure applied was a floating rectangular piece with 6 ropes hanging down from it, and this structure was placed in the center of the cages with treatment. Therefore, the environmental enrichment looked like this. The enriched group had the structure in the middle and the ropes covering 3/4 of the cages, and the control one was completely empty. So this experiment is already done, and now we're working on the occupational enrichment experiment. In fact, this experiment has been setting up over the past month, and just yesterday, the official experimental period began. So what I'm talking about today is the results about this physical experimental enrichment. So as I said in my objectives, I want to compare the effects at 2 different temporal scales. One is after 3 months of being reared under this enriched condition, that we understand that is the short-term effects, and also after 9 months of being reared under enriched conditions, that are the long-term effects. In the middle of these 2 periods, there were a period of 3 months that the individuals were not manipulated at all, so no data were collected during this period. Particularly, the results I'm going to show you is from the short-term part. In our study, we would like to analyze each, we want to make a complete evaluation of welfare, and that's why we perform analysis on each aspect of welfare. Today, I'm going to present 2 behavioral tests that are the emotional reactivity test and the maze resolving test, and also some of the physiological analysis that we perform at the moment. Starting with the emotional reactivity test, we conduct this test for 4 consecutive days, testing 10 individuals individually from each cage, reaching a total of 80 individuals tested. This test consists in placing a fish in the center of a circular tank that it had never explored before. And their behavioral response were recorded on video for 10 minutes with the top camera view. And what we are interested in is the way that the animal explored this new environment, the area that they used. So with just a quick look of these two videos, here you can see the fish, where I don't know where is he, here, moving around, and there was a fish. This video is played. So could you tell me which one is the enriched fish? Exactly. The result tells us how the enriched group travel a greater distance in this emotional reactivity test on the second day test and also globally. And if we focus on this daily variation, how the distance travel changes, we see how the first day for the enriched group shows minimal values on the distance travel. After these days, they increase their locomotion, and follow this second day, we can observe a reduction in their movement. In the case of the control group, maximum values were obtained the first day, followed by a reduction in movement during the rest of test days. What we also want to analyze is the area that these individuals used. And these are the results about it, and we are showing the cut values, which represent the area used by the individuals. In this case, we present the 95% cut, which reflect the general area used by the individuals. In this case, we observe again higher areas explored by the individual during day 2 and 3, and also globally. And again, if we focus in this daily variation, we observe how the first day the area explored was minimal, followed by an increase in this area explored that is maintained during day 2, 3, and 4. And for the non-enriched treatment, no difference between days was observed. I forgot to tell that these line diagrams are very important. I want you to keep them in mind because later will be important. So this is another parameter that reflects the area used by the individual. In this case is the 50% cut. We represent the area the individual used more frequently. So in this case, more or less the same results was observed. Higher area used by the individual by the enriched group on day 2 and also globally. And regarding these daily variations, more or less the same pattern was observed with minimal values on day 1, followed by an increase in the area explored, and then a reduction of the area explored for the enriched group, and the control group, no difference between days. So the next behavioral test that we perform is the maze resolution test. In this test, we also do it for consecutive days, and in this case, we analyze groups of 5 individuals per cage. So we reach a total of 40 individual reach for testing. The maze consists in a tank divided into 5 compartments with 4 walls. Each wall has 2 doors, but only one can be crossed. The other one was blocked with a transparent box, so the individuals can see through it, but they cannot cross it. So obviously, the objective of this test was that the individual has to swim from the first compartment to the last compartment, that where is the reward that is put. And again, with just a quick look of these 2 videos, could you tell me which one is the enriched? Great. The results about this test is showing more or less this. Here we are presenting the time the first individual needs to cross each maze door in each test day. So what we can observe, the enriched group was the only one that solved the maze on day 1. In second day, both groups solved the maze, but the enriched group solved it faster. And as a direct reflection or image or graph about the resolution of the maze, we show the time also that the individual needs to cross the last door on each test day. And here we can see the daily variations of the resolution of the maze. And in this case, the enriched group solved the first day. And after this day, a reduction in the resolution time was observed, a very abrupt very heavy reduction in resolution time. And in another hand, the control group didn't resolve the maze on day 1. They resolved it on day 2, and there we observe a slightly reduction in the resolution time. So when we complete these behavioral tests, we sample all tested individuals, collecting muscles and brain tissues for an oxidative evaluation of their oxidative status by measuring the activity of 3 antioxidant enzymes and the MDA concentrations. About this, I have to say that the increase in activity leads to an increase in the ventilatory activity to try to prevent oxidative stress, which is understood as the stream formation of reactive oxygen species, which can cause oxidative damage at the cellular level that is reflected with an increase in MDA concentrations. So the organism, to try to reduce these reactive oxygen species, activate antioxidant enzymes, and that's why the MDA concentration and the activity of these antioxidant enzymes are used as markers of oxidative stress. The results show how the activity of catalase and SOT, here is the name, are higher in the enriched group in the muscle. And regarding these two, the activity of GRD were no different between treatments, and also in MDA concentration, we didn't find different between treatments. So as a general conclusion, we can say that the fact that the distance traveled by the enriched group and the area explored by these individuals were greater, and also the maze resolution was faster, suggests that the environmental enrichment, or the physical environmental enrichment, enhance their exploratory ability and their exploratory behavior and cognitive abilities during these resolving tests and during a situation of stress management. And regarding these daily variations, Matsunaga in 2020 defines 3 habituation phases for the Japanese dry fish. He describes that in the first phase, the individual showed the diving response, staying at the bottom without any kind of movement. After this phase, on phase 2, their locomotion increased, and in phase 3, their locomotion decreased because of the habituation. If we go back to these line diagrams that shows the daily variation, we can see how the enriched group, where is the bottom? The enriched group matches perfectly this habituation process described by Matsunaga, but the non-enriched group didn't show at all this habituation process. And also, in the maze experiment, in this case, both show this habituation process, but the enriched group reached the phase 2 on day 1, and therefore the phase 3 was observed during day 2, 3, and 4. In contrast, the non-enriched treatment, the phase 2 didn't appear until day 2, and the habituation phase appears on day 3 and 4. So the fact that we didn't find this phase 2 in the emotional reactivity test, or this phase was delayed during the maze test in this control group, indicate that this individual have no exploration attempts, or that they have difficulty to begin their exploration, reflecting their high level of anxiety that blocked or delayed the normal habituation process to happen. In another hand, the fact that we find this phase 2 in the emotional reactivity test, and this phase 2 was earlier during the maze test for the enriched group, indicates a predisposition to acquire new information, and that this individual have no fear to explore the environment, reflecting their less level of anxiety that allows a normal habituation process to happen. If we go back to the physiological analysis, we see how this increase in movement during this behavioral test leads to an increase in SOT and CAT activity. But we understand that this increase is positive because the MDA concentration didn't differ between treatment and no tissue damage had happened. So therefore, we understand that environmental enrichment contributes to improve resilience against adverse conditions. So as a global conclusions, we can see that the physical environmental enrichment had increased They're active exploratory behavior because we obtain higher values on distant travel and area use during the motional reactivity test. Also, we can say that this enrichment increased their cognitive abilities because in the maze experiment, the enriched group do it faster. And finally, we found an effective activation of antioxidant enzymes without causing cellular damage. That's why we understand that the impact of this enrichment was positive on their mental conditions, and therefore it can enhance their cognitive attestation during a stress test and also during problem resolving. And that's why we conclude that this type of environmental enrichment can enhance welfare and can contribute to the achievement of positive welfare in European seabass. Thank you.
Thank you very much, Maria. Any questions?
So very interesting. I don't know exactly whether, but let's see what do you think about it. So in-house aquariums, right? I guess you might have something similar problem, meaning that you want the fish to be healthy, right?
Yeah.
But in general, when you start, at least you have a pretty skint, sort of very basic sort of aquarium. Do you think, I mean, is there any study that you know of how successful is your aquarium attempt versus the, let's say, the features that are available in the aquarium for the fish to sort of explore? Because it's a similar thing, right?
I know there are a lot of studies that investigate the effect. I mean, there's a lot of studies that say the environmental enrichment is positive in aquarium too, but I'm not really sure which particular articles, but I know there's a lot of research about it, and they obtain positive results, mostly about the structural environmental enrichment. That's why a lot of aquariums have like plants and those type of figures, because they know that this kind of environmental enrichment is helpful for the welfare of the individuals. But I don't know if there's more research about like the different types of enrichment in aquarium level. I'm not pretty sure about it.
No questions?
I'm not convinced that you can use the time it takes to solve the maze
Okay.
as, you're using the time it takes to solve the maze as a proxy for cognitive ability. But one of the groups moves much more than the other. So of course, it's gonna take less time for one than for the other to solve it. So yeah, you know what I mean?
Not really, but
So one is moving all the
Yeah.
time. So just by sheer luck and by, attempts, it's gonna take much less for one group than the other.
exactly. But the one that are able to explore this environment is able to solve it, and it's a reflection of a resolution. I mean, once the maze are solved, then they have 1 hour. I didn't tell it, but this records for 1 hour. So once the maze is solved, then they have time to explore everything, and it's like a double check of the emotional reactivity test that reflect the exploratory ability of the fish. So the maze test explore how they can learn how to solve the maze, and that's why in the consecutive days they reduce their time, and also the exploration of this maze that is also a new environment to explore. So-
It's less the second time.
The resolution of the maze.
Yeah.
Yes, sure. That's here.
But it's the same fish.
Oh no, I told one here. The second day, the resolution of the maze was really shorter.
Okay, so okay.
Yeah, I was wondering, are you keeping track of the individuals when you do the? so you
We
know
tried to. We tried to, but this analysis was performed by a group in Madrid. and they have issues to track each individual because they colabarse entre ellos.
No, I mean in between different experimental days.
Yes,
So that the individuals in day 1 are the same as
Yes.
in day 2 and day
yes.
3.
The same individuals in maze and also in the emotional reactivity test was the same
Oh, I see.
individuals. That's why we can see the habituation
Yeah.
of these individuals.
So you were not testing all the individuals in the cages because I don't
No.
remember how many individuals were per cage.
500 en cada cage.
Wow. So you were taking 10
Yeah,
for 4 days out of the cage, or you were? I mean, you were not.
no,
putting
we
them back.
cannot put it again on the
Okay.
cage.
And you repeated the experiment, or you did it, how many times did you did it? You took the 10
Yeah,
fishes, did the experiment, and then you did it again?
no, we
No.
did it for 4 consecutive days with the same individual, but we didn't do it again. Well, we did it again for the long-term effect, but the results are not analyzed yet.
And there will be different individuals in this case.
Exactly.
And here, so you have in each day 4 replicates of each. Because I mean, the individuals of
Yes.
different cages were treated differently.
Well,
I mean, you had different, and there were 3 control cages. or
there
4?
were 4 control cages and 4 experimental cages. So we test a group of 5 individuals per cage. So 4 groups of 5 per treatment.
And do you have any difference between cages, for instance?
No, they're no different. When I do the statistical analysis,
Yeah.
the effect of cage was not significant.
So I don't know if these fish are sort of, they have a group structure, or I was wondering what would you expect if you were to mix individuals from different let's say
Cages.
training regimes, and whether the ones that have not been stimulated would sort of follow the other ones, and for example find the food in a similar amount of time as the stimulated fish.
I don't know how to say hierarchy in English.
Yeah.
Hierarchy, vale. Pues the hierarchy of the seabass is easy study. There are a really complicated hierarchy with an alpha and there. But in fact, in the maze test, the fact that we put 5 individuals per cage, this is like un análisis primario. O sea, I mean, there's a lot of things to study when you put 5 individuals in the same cage. Even if it's from the same cage, this hierarchy can be observed too. So I think that if you mix 2 cages, these 2 groups didn't know each other. So this hierarchy will be multiplied, or the effects of the hierarchy would be multiplied. But I don't really know what would happen. So in fact, in the results of the maze, in some videos, you can see how there's one individual like looking for the other one and try to fight. So in the same cage, this hierarchy happens. And there's a lot of things that you can study with this test. That's one of the reasons, because we put 5 individuals on it.
It's true that we haven't tested that mix the stimulated and the non-stimulated. And we can hypothesize on that because there are some other studies on that for the one hand we have the social contagion, so they can learn from each other. But also there's the social habituation, that if they don't know each other, if they come from different groups, families, or they can fight. And that can go against of the learning process. So specifically with seabass, is a very sensitive species, and we don't really know what could happen or one thing or the other thing. But we didn't test it, and this is really interesting. It would be nice to see that. So it depends also on the species and also on the life stage. When they are juveniles, they are more stressful, but also they are more social. When they are adults, they behave completely different, so they can adapt. They're a bit more relaxed. They don't fight as much as when they are juveniles. But yeah, it's very interesting. We don't know yet that. We plan to do that, but there's no time in the PhD.
No.
I hope, yes, but no, I don't think so.
Did you compare your results with other studies on other species? Is this something the results you have are expected? Or it's different from other species if there are studies like
Yeah,
this
yeah,
one?
there are a lot of studies about it, and it depends on the species, the type of enrichment. Sometimes an enrichment doesn't fit the necessities or the needs, the physiology, behavior, and mental needs of each species. So there are a lot of range of results. Sometimes an enrichment helps a species but doesn't help another one. So there are a lot of variability in the results.
So it's very specific to the species.
Okay, so we can leave it here. Thank you very much.